and adding them. So what are some things we know about decimals? Okay.
They involve numbers.
Yeah?
They have a whole number and then a sort of fraction after.
Excellent. Yes.
When you say like the decimals, you would say
And. Very good.
They are used in money.
They're used in money. That's really important for this lesson. Yes. They can. And do you know how to change them? Yes? Okay, what?
I was just giving percentages.
Yeah. They're all related. So if I take the number 1/2, I know that that's what decimal.
50%.
How do I?
0.5. Yeah.
0.5, right?
Right.
How do I know that?
Because 1/2 is 50 equals 50.
Right. It equals 0.5 or 50%. What? But if I wanted to figure it out and I didn't know it, I know that a fraction over 100 is a decimal, correct?
Yeah.
So I have to multiply 2 times 50 to get 100. So then I have to multiply 1 times 50. Because what I do to the bottom, I have to do to the top in a fraction. So then I get 50 over 100, and I know that anything over 100 is a decimal, or anything over 10 actually could even be a decimal, but this would be 5.0.
Oh, I thought you meant like 10 hundreds or anything over 10 hundreds.
It's true, yes. And then when I have it over 100, and I have it like that, I know that to make a percent, I move the decimal 2 places to the right and add my percent sign, right? Because a percent means I move 100. So we have that down. All right? So we said that a decimal, somebody said that a decimal is a number that has a whole part, and then it has a decimal point, and then it has digits after the decimal point, or to the right of the decimal point, right? And these digits to the right of the decimal point mean a portion of a whole, right?
Right.
They're like a fraction. And so, what are the place values of these numbers?
The first one is 10.
Yes?
100.
And then I could go on to thousands, right? So, I didn't hand out your packets, but I have packets for you to follow by. So a decimal is a number with digits to the right of the decimal, right? Okay. Now,
What is RTV?
right, RT is right. Someplace here. Okay. Pass these out to this class. And would you pass these out to this class? What I have going out to you are just packets with problems that I've written out and information I've written out. It's just a guide for you to go through and take notes and work problems. I may or may not go through all the problems on this, because you guys are smart.
Doesn't matter.
All right,
This isn't
so
going anywhere.
while you're handing that out, my first example is 2.75. How do I read 2.75?
275.
Yeah?
2,7,500.
Very good. 2
Can I switch?
and 7,500. So this 7,500 means that I'm taking one whole unit, or like one whole dollar, and I'm breaking it up into hundreds. So if it were $1, I'd be breaking it up into pennies, wouldn't I?
Right.
To take pieces of it. And this would actually be 75 cents, correct? So a decimal can be a whole and a part, or like the next example, a decimal can be just a part of a whole, and it can have a 0 here. And in that case, this decimal is read, what is this one? 0.33 is 33 hundredths, right? What about, oopsie, down here I have 2.5. How do I read 2.5? Yeah?
Oh, sorry, I was.
Oh, okay. 2 5/10. So this is 2 whole units and 5/10. Okay. So now we know decimals. And we're going to think about, we're going to learn about, yeah? Sure. We're going to learn about multiplying decimals times a whole number in this lesson. So, why do you think you want to know how to multiply a decimal times a whole number?
Because like if you're working for some place, or it's like you're eating pies with a friend or something, and you've already eaten a certain amount, and I'm trying to guess.
You're on to something. What?
Like with money, like you have a whole dollar, but then you have some cents.
Perfect. Decimals are money, and stores have sales, don't they?
Yeah.
And when stores have sales, they take a percentage off of the full price. And so that leads me to my example. That was perfect. Later, after we do this lesson, I posed a problem to the class this morning, and that is, we're going to pretend that there's a brand new iPad that just came out. All right, generation, what are you? 5, okay? And you have generation 2. You really want this new iPad. The iPad costs $600. I mean $800. Sorry, $800. Right? So the iPad costs $800, and you have $600 saved. July 4th weekend, Best Buy is having a really big sale on iPad Generation 5. And they're going to take 20% off the price of an iPad, or 0.2. Do you have enough money with your $600 for that iPad?
No.
How do you know?
Because half of eight is 400, and that would be enough. But it's only 20%, and like if you take off like 20% of 800, it'd be 700, I think.
Not quite, but you're close. You're on to it. Yeah?
She doesn't have enough to afford the iPad because 10% of 800 is 80, and 80 plus 80 is 160, and 800 minus 160 would be 640, so she needs $40 more.
Wow. I'm impressed. Did anybody think of that?
This guy.
That was, what do you guys do? What's the clock? 1, 2, 3. That was excellent. That was perfect. What you did is you multiplied 800 times 10%, right? So, and and you got $80. How did you know 10% times 800 was $80?
Because 10 times 80 is 800.
Excellent. So you figured it out. So 10% of $800 is $80. So 20% would be 80 plus 80, or $160. So what's the new price of my iPad with the discount? Right? That one. Yeah.
It would be $700.
Now we're doing $800 minus
Oh, probably doing
$160.
that'd be 0, 0, 0, and then another 0. But cross out the 8, make it a 7. Cross out the 10, yeah, and then it's 4. And then
So the new price is $640, and you have $600.
Oh,
So close. But the good news is it's only the end of May, and you have more than a month to save up,
yeah.
right? You have a question?
No.
Okay.
My mom
All right.
does the rest.
That was really smart thinking. What we are going to do is we are going to get to doing problems like this. And I have one that's even more interesting at the end. But we are going to start at the very beginning of multiplying decimals. And we're going to do very easy problems showing you the process of exactly what you're doing when you're multiplying by a decimal. And then we're going to quickly go on to more interesting, more fun problems. And then a way to multiply them that's really simple and easy. Okay? In 6th grade, you will have multiplying these decimals with money on your FCAT. So your teachers will be going over this a lot with you. So, I am going to start with going back to multiply. This is just a quick review. When I multiply a whole number bigger than 1 times another whole number bigger than 1, what's my answer going to be compared to the numbers I'm multiplying?
Whatever your like, not the number.
5 times 3, what's my answer? It's going to be bigger or smaller? It's going to be a whole lot bigger, right? Because I'm taking 5 and I'm making 3 groups of 5. What about when I multiply a number times 1? What's my answer? It's always going to be that number. 1 times any number is that number, right? They call that identity property of 1. 1 times any number is that number. What about 0 times a number?
It equals 0 because there's no 5 times 1 equals 5 because they're
5 times 0 times anything is
0.
perfect.
Because it's that number 0.
Right, right. So, 0 times a number is 0. 1 times a number is that number. What about all those numbers between 0 and 1, like 0.25, 1/3,
All the answers
0.6? The answer is always going to be how compared to the numbers I'm multiplying? Lower, smaller, right? Because I'm taking a piece of the whole that I'm multiplying it by when I'm multiplying by a number smaller, right? Like 3 times 1/4, I'm really dividing 3 by 4 and taking one of those groups. Okay? So remember that when you're multiplying by decimals, that whenever the decimal is less than 1 and it only has digits to the right of the decimal point, my answer is going to be smaller than the number I'm multiplying by. So let's just keep that in mind. And we'll go to our first problem. And I know you all are going to whiz through these problems. If you just turn your page, and then we can get to the fun part. All right, here's my first problem. 1 times 0.5. Why do I have a tens block here for us to use to figure out 1 times 0.5?
Because the 5's in the tens place.
Excellent, right. So the first step is to always notice what place value the decimal has. And we always look to the number furthest to the right of the decimal point. And we know that when we're multiplying a whole number times that, I'm going to break that whole number up into that equal units. So if this were, well, we'll get to that. Now, I'm taking 0.5. So how many of these blocks am I going to shade in to get my answer? Yeah? 5. So, and what's my answer? 5 out of 5 out of 10 segments, right? Because I took 1 and I divided it up into 10 segments.
It's actually 5 out of 1 whole.
Well, yeah, it is 5 out of 1 whole, but I've divided that whole up into 10 segments. And you're right, it is 5. It's 0.5 out of 1 whole. Right, which is 1/2. So what's my answer going to be? 0.5. 0.5, right?
Right.
I could have also done this with the identity property because it's 1. 1 times any number is what? Is that number. So I automatically know that my answer is 0.5. Yes?
It doesn't matter if the 0 is there, right? Does it matter if the 0 is before the 5? 0 and 5 cents.
This 0 in this place means I have no 1s, right? Because it's the 1s place. The 5 here means I have 5/10 of 1 whole. A 0 here just means I have 0 hundredths. It doesn't matter whether I fill in the 0 there or not. The only time that it would matter is if I want to write 0.05 or 5/100ths, then I would have to have this 0 here as a place filler and put the 5 here, right? So this was easy, wasn't it?
Yes.
I could also think of 50 cents out of $1, right? And I know it's 50 cents. All right. Let's try the next one. 2 times 0.5. Is that going to stay? Yeah. So, in this case, what would it be? It would be $1. But why? Tell me why. How many of those 2 would I shade in? Right? I would shade 5 here. Right? Is that 5? Yeah. And I would shade in 5 here. Right? And I would get 0.5 plus 0.5 equals a whole 1. Does everybody agree? Yes? Right. In this case, I have my 2 whole units divided up into groups of 10 because the 5 is in the tens place. And then my answer is 5 of each of these, or 5/10. And 5/10 plus 5/10 is what? Right? Good. So not so bad, right? Let's see the next one. Next one. And the actual problem is not written on your sheet, but it's 3 times 0.5. If you write that in on top of your paper. 0.25, yeah. 3 times 0.25.